how strong are acid or base solution. Okay, how strong are acid or base solution? We have discussed about indicators, natural indicators and synthetic indicators. What the indicators means?
So it indicates that the solution is acidic or basic.
Yes, indicators indicate that whether the solution is acid or base by
So by changing its smell or color.
changing the color. By changing the color. Okay, but it will change only one color, like blue litmus paper. If you are taking, then it will change to the red. Only one color will show. If red litmus paper, if you are taking, then it shows it will be changed to the blue color. There will be changes of only one color. So indicators indicate that whether the solution is acid or base by changing the color. Okay, then it will not indicate that whether this acid solution is a strong, whether it is a base solution is a strong or weak. Okay, it only indicates that the solution is acid or base. That's it, by changing the color. But we have to find out, so whether the solution is strong or weak, whether the acid or base solution is strong or weak. For that, we have to use one indicator that is called universal indicators. Okay, it is called universal indicators. Universal indicators we have to use. Universal indicators. This indicator is actually the mixture of several indicators. Universal indicator is a mixture of several indicators. This indicators also will change the color. This indicator also will change the color, but this indicator show different colors. Almost 14 different colors will show. This indicator will show 14 different colors at a different concentration of H plus ion, at different concentration of H plus ion. The different concentration of H plus ion. So this indicator, universal indicators, not only show the color, but also will help us to say that which acid or base solution is strong and weak. By saying that, by measuring the concentration of H plus ion. Based on the concentration of H plus ion, it will show the different colors. What is mean by concentration of H plus ion? Okay, example, now this universal indicator will show different colors. It will show different colors at different concentration of H plus ion. It means if the H plus ion, the concentration of H plus ion is more, then it will show different color. If H plus ion is less, then it will show the different colors. So almost how many colors it will show? 14 different colors will show. How many different colors?
14.
14 different color will be showing by the universal indicator. Based on what? Based on the concentration of H
plus ion.
Based on the concentration of H plus ion. So what I can say that universal indicator is a mixture of several indicators. It's a mixture of several indicators. It's a mixture of several indicators, and it show different colors. It show different colors at different
Concentration of H plus ion.
Concentration of H plus ions.
concentration of hydrogen ion. You can say that what H plus ion is also what called a hydrogen ion. In the bracket, I will write H plus ion. Okay. A different concentration of H plus ion in a solution. In a solution. So universal indicator is just like a strip of paper. Okay, that will be brown color. Okay, the strip of paper is just like a strip of paper. Okay, universal indicator is just a strip of paper. So this strip of paper, when you will put any solution on this strip of paper, okay, if you put any solution on the strip of paper, means universal. This is the universal indicator. Universal indicator is just like a strip of paper. Okay, when you will put any solution in this strip of paper or universal indicators, it show the different colors. It show different 14 colors. Okay, any one color it will show. Okay, and based on that color, we can able to find what is that solution, whether it is acidic solution or basic solution, and also we can able to find whether this solution is strong or weak. Okay, based on that solution we can say that whether that solution is acid is or basic, and whether this acid and basic are strong or weak. Okay, based on that. So like some colors, like if I say that dark red color, some red colors, okay, orange red colors. Okay, so if pH is 0, if this is the pH is equal to 1, if the pH is equal to 2, then show this color. Okay, pH equal to 2 also will show the red color only, pH 1 and 2. Orange red will come show you pH equal to 3. Okay, and pH is equal to 7. If pH equal to 7, then it is show the green color. It show the green color. If the pH is equal to 8, then it show the greenish blue color. Greenish blue color. Okay, if pH is equal to now 12. 12 means it will show the dark purple. Dark purple it will show. And if pH is equal to 13 and 14, it will show the violet color. Okay, so likewise, so many, only 14 colors it will show. This indicator will show 14 different colors if you put any solution on this indicators. Okay, like a different 14 colors. Based on what it show the different 14 colors, it show the different 14 colors at a different concentration of hydrogen ion concentration, hydrogen ion in a solution. At the concentration of hydrogen ion, what is it by concentration of hydrogen ion? Nothing but some acid will produce more H plus ion. It means the concentration is more. And some acid produce less H plus ion. It means the concentration is less. That is called what? Concentration of hydrogen ion. Okay, so this indicator, so based on that concentration of H plus ion, that indicator will show the colors at different colors. Okay, so this is only not useful. There's one more scale we have to use. Okay, what is that scale name? That scale is a pH scale. That is called what? pH scale. We will require one more scale, okay, for identify what is the strength of the acid or base. That scale is called what? pH scale. That scale is called a pH scale. P means what? Power. P means power and H means hydrogen. Means strength of the hydrogen. Strength of the hydrogen, nothing but what is the concentration of H? Nothing but concentration of hydrogen ion. The pH scale. What is the pH scale? This just like a one strip of paper. Okay, this just like a one strip of paper. But in this strip of paper, we have 14 different colors. In this strip of paper, you can see 14 colors. Okay, in this strip of papers, you can see the 14 different colors. Okay, 14 different colors you can see. Like 0, pH equal to 0, pH equal to 1, pH equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So in this pH scale, you can see 14 different colors at different pH values. Okay. So the dark red you can see and the pH equal to 0. The pH equal to 1 and pH equal to 2, you can see the red color. And in the pH equal to 3, you can see the orange red colors. pH 7 is the green color. Okay. pH equal to 8 is the green blue colors. 12 is a dark purple. Okay. Dark purple. 13 is the violet colors. Violet. Others name is not need to remember that. Just for this color name is not need to remember. Just for the, I give an example. Few here color name here and the last color name. Okay, just for the idea, what are the different colors this pH scale having? This is actually the pH scale. In this pH scales, you have in this pH scales, there is a 14 different colors. There are 14 different colors. Okay. At different pH value, there are 14 different colors. So example of pH is equal to 0. At this pH value equal to 0, what color you have?
Dark red.
Dark red.
Dark red. Okay, like this. So this pH scale, only you can see the colors. All the 14 colors at different pH value. So what is the use of this pH scale? What is the use of this pH scale? So the pH scale is nothing but what it is used for measuring. The pH scale is nothing but it is used for measuring the concentration. It is also used to measuring the hydrogen ion concentration. Okay, this is used to measuring the hydrogen ion concentration. A scale for measuring hydrogen ion concentration. Hydrogen ion concentration. Okay, a scale for measuring hydrogen ion concentration in a solution. Nothing but water. It show you that the how much hydrogen ion concentration is produced. Okay, it shows that how much, whether it is more hydrogen ion or less hydrogen ion. Nothing but whether the solution is a strong acid or weak acid, or whether the solution is a strong base or weak base. So in this scale, what is, you can see that on this case, on the pH scale, we can see that on the pH scale, we can measure what we can measure. We can measure the pH from, okay. So on the pH scale, we can measure the pH from 0, pH equal to 0. pH equal to 0 is actually called very acidic. To 14. 14 is called very alkaline. The 14 is called very alkaline. Very alkaline. So see here pH is equal to 0 and pH is equal to 14. pH is equal to 0. If the pH is equal to 0, it is a very acidic. Very acidic, nothing but water. It is a strong acid.
Strong acid.
And if the pH is equal to 14, then it is called water very
Strong base.
alkaline. Very alkaline, nothing but water
Strong base.
strong
base.
strong base. And there is a middle value. What is the middle value? pH is equal to 7. pH. Okay, the pH of a neutral solution. What is the pH of the neutral solution? The pH of the neutral solution is 7. So what is the pH scale? The pH scale is nothing but what is used for measuring hydrogen ion concentration. It is used for measuring water hydrogen ion concentration. It is used for measuring hydrogen ion concentration. So here I'll just draw here a pH scale. So in this pH scale, this is the here you have the middle, that is what pH is equal to 7. Okay, pH equal to 7. Suppose if you are going less than 7, if you're going left hand side, from 7 to 0, if you're going from 7 to 0, in this what will happen? There is a increase in H plus ion concentration. Increase in H plus ion concentration. And if you go from more than 7, if you go right hand side, if the pH equal to greater than 7, that will have, what will happen here? Decrease in H plus ion concentration. Decrease in H plus ion concentration. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So now you see 0 to 7. If you will go 0 to 7, sorry, 7 to 0, if it's less than 7, if you're going less than 7, then if there is a, if you are going from less than 7, okay, if you're going left hand side, 7 to 0, that time what will happen?
Increase in concentration of H plus ion.
Increase in H plus ion concentration. Increase in H plus ion concentration. 7. Okay. And this is the neutral. Okay. And what will happen now if you're going from left hand side? If you're going right hand side, sorry, right hand side.
Decrease in H plus ion concentration.
Decrease in H plus ion concentration. Decrease in H plus ion concentration. It's nothing but on the left hand side. On the left hand side, you have which solution? You know, on the left hand side, you have acidic solution. Or we can say that acidic nature will be increasing. Acidic nature is increasing. And the right hand side, what will happen now? Basic nature is increasing. Basic nature is increasing. Okay. Basic nature is increasing. So here, if you are going left hand side, 7 to 0. So which nature will be increasing?
Acidic.
Acidic. 7 to 0 is an acidic. So what I can write here, value less than 7, value less than 7 on the pH scale. The value less than 7 on the pH scale represent an which solution?
Acidic solution.
Acidic solution. And value more than 7, value more than 7 on the pH scale represent an
Basic solution.
basic solution. Basic solution, correct. Basic solution. Basic solution. So what is the, now here value less than 7, pH less than 7 on the pH scale will be acidic solution. It will show the acidic solution. Okay, and if it is greater than 7, means if it is the pH is more than 7, then show the basic solution. Okay, so here the one more point I can write water. One more point what we can write. The another point what we can write. As the pH value decreases from 7 to 0. As the pH value decreases from 7 to 0, what it represents? If the pH value decreases from 7 to 0, then it represents and what? It represents an increase. What it represents? An increase in
H plus ion concentration.
correct. H plus ion concentration. Exactly correct. Increase in H plus ion concentration. Next one, if I write here, as the pH value increases from 7 to 14, then it represent what?
Decrease in H plus ion concentration.
Correct. Decrease in H plus ion concentration. And one more thing, if you want to write, if you do not want to write decrease in H plus ion concentration, then what is increasing here? Here, what will be increase? If you go for
Basic
what will be increase?
OH minus.
Yes,
OH minus.
because it is a basic nature increasing. Basic nature increase is nothing but there is an increase in OH minus ion concentration. Yes, correct answer. OH minus ion concentration. Here, OH minus ion concentration is increasing. Okay, OH minus ion will be increasing. If the pH value is increases from 7 to 14, 7 to 14, if you will go, then the OH minus ion increases. You have the acid, right side you have the base. Left side from 7 to 0, H plus ion is increases. Right side OH minus ion increases. Left side H plus ion increases. Right side OH minus ion increases. Okay. And what is the another point you can write in this? Suppose now here if I ask one question to you, pH, if the pH is equal to 2, one more point, yeah, before that just will give one more point. Higher the concentration, see this point is also very important. Higher the hydrogen ion concentration, means H plus ion concentration, hydrogen ion concentration, lower the pH value. What is the lower is the pH value. This point. Higher the hydrogen ion concentration, lower the pH value. It means what? What is the meaning of that? Now, if I ask now here, pH is equal to 2. If any solution is pH equal to 2, and some solution pH is equal to 5. Now, in this pH is equal to 2 and pH is equal to 5, which solution having a higher hydrogen ion concentration?
pH is equal to 2.
pH is equal
pH
to
is
2.
equal to
pH is
2.
equal to
Yes. If the pH is equal to 2, the pH equal to 2 solution having a higher the hydrogen ion concentration. See this pH equal to 2 and the pH equal to 5. So the pH equal to 2 is the higher ion concentration, higher the hydrogen ion concentration. And the solution which having the higher the hydrogen ion concentration are called what? Strong.
Acidic solution.
Acidic solution, but that acidic solution is what? Strong acid.
Strong acids.
Strong acidic solution. So if the pH is equal to 2 and pH is equal to 5, which is the strong acid?
pH2.
pH equals
pH2 is the strong acid then the pH is equal to 5, and the pH 2 also having the higher hydrogen ion concentration. Higher the hydrogen ion concentration. Okay. Now suppose if the pH is equal to 4, then whether it is an acid or base?
Acid.
Acid.
pH
Acid,
is
sir.
equal to 4 is the acid. If the pH is equal to 7, whether it is an acid or base?
It is neutral, sir.
Neutral, sir.
Neutral, sir.
Neutral, sir.
It is a neutral. If the pH is equal to 12, then whether it is acid or base?
Base.
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 Base. If the pH is equal to 14, then whether it is acid or base?
Base.
Base. If the pH is equal to 10, whether it is acid or base?
Base. Base.
Base, sir.
Base, correct. It is a base, exactly correct. Okay. Now here if I'll ask one question, if the pH is equal to 11 and the pH is equal to 30, pH is equal to 11 and the pH is equal to 30. Okay. Which solution having the higher the concentration of OH minus ion?
pH 13.
pH 13.
pH 13.
pH 13.
Higher the concentration of OH minus ion, nothing but pH is equal to 30. Concentration of OH minus ion, higher the concentration of OH minus ion. Okay, so what I can write here, next point here, higher the hydroxide ion, higher the hydroxide ion concentration, higher the hydroxide ion concentration, then what is the pH value? pH value also higher. Higher the pH value, higher the hydroxide ion. Higher the pH value, higher the hydroxide ion. If I'm taking pH is equal to 10 and pH is equal to 40, okay. So these are actually base, but which having the higher the hydroxide ion, which having the higher the hydroxide ion?
14.
pH 14.
pH 14.
pH 14 having the higher hydroxide ion. So in this pH 10 and pH 14, which is the strong base?
pH 14.
pH 14.
pH 14.
pH 14 is the strong base. So what I can say that the solution having pH 0, 1, 2 and 3, okay, are strong acid, and the solution having a pH 4, 5 and 6 are weak acid. And if suppose now the solution having pH, what is the pH? 8, 9 and 10 are what is called
Weak base.
weak base.
Strong base.
Weak base, dear, weak. 8, 9, 10 are weak base. pH 11, 12, 13 and 14 are
Strong base.
strong base, correct. They are called a strong base. Why it is called a strong base?
So So because it has more concentration of hydroxide ion.
That is the perfectly correct answer given. See that any base, if it is strong base, then it having the more or higher the concentration of OH minus ion. Higher the concentration of OH minus ion. And suppose why this having the weak acid, why it is called weak acid?
Less concentration of hydrogen ion.
Yes, less concentration of hydrogen ion, exactly correct. And why we are called a strong acid?
More concentration of hydrogen ion.
More concentration of hydrogen ion, exactly correct. So if you want to write the definition of a strong acid, then what you can write the strong acid? So acid, okay, what I can write, that acid that give rise to more H plus ion. Okay, more H plus ion. Acid that give rise to more H plus ion are said to be strong acid. Are said to be strong acid. So which acid give more H plus ion? That acid is called what? Strong acid. So what example you can write for the strong acid? The first acid is called hydrochloric acid. Another one is sulfuric acid. And another one is what? Nitric acid. Okay, don't write only the formula. You have to write the name also. Hydrochloric acid. Hydrochloric acid. HCl. Next, you have sulfuric acid, H2SO4. Sulfuric acid, H2SO4. And the nitric acid,